Welcome back to another Daishinfinity video. In this video, we're going to prove the addition theorem of sine. And it's not addition, it's actually subtraction of two angles. We can see it's sine of alpha minus beta. And in the last video, I very apologize that the sine of alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha. The proof actually was completely right. And in the last how do you say, in the last proof section, I actually ignored to write the plus and then just wrote the minus because the title was sine alpha plus beta is equal to sine alpha cosine beta minus sine beta cosine alpha. Even it should be sine alpha cosine beta plus sine beta cosine alpha. So I was just thinking, okay, because the title should always be right, my proof is somehow wrong or something, and that's why I ignored it. But actually the proof was right, so everyone who recognized it, please, I apologize for you guys, and next time I'll try my best to do everything in the right direction. So in this video we're going to do addition theorem, subtraction between two angles alpha and beta. Now we're going to use the Euler's formula, which means we can use the Euler's formula e to the I alpha, which is also defined as cosine alpha, which is the real part of the complex plane, cosine alpha, plus I sine alpha. So all of the alphas, whatever alpha we pick, it's always in the unit circle of the complex plane. Since we don't have a radius r multiplied by the e to the I of alpha, so we can just take this the sine alpha and then define sine alpha as a sum of e to the I alphas. And the question is, how can we do it? We can always define a function f of x given by the sum of two different functions. The first function, we're just going to take the even function, which says that f of x is equal to f of minus x. So if we multiply, if we add both of the f of x and f of minus x, we would technically have 2 f of x. So if we divide both sides by 2, we would have the function f of x. So the even function. Now the odd function goes as follows. We have f of x minus f of minus x over 2. So this should be cosine alpha. So e to the I alpha should be the f of x, and this should be the I sine alpha. But we don't want I sine alpha. We would like to have sine alpha. So let's just write it as follows. I sine alpha is equal to f of x, which is e to the I alpha, and then minus e to the negative I alpha, since f of minus x is e to the negative I alpha, over 2. Now dividing both sides by I is not negative, not 0. So we can just do it as follows, and then we can take the fraction outside and then just represent the sign as follows. And since we have this, we can now plug in the alpha plus beta in the input. Alpha minus beta, so that we can write sine alpha minus beta is equal to 1 over 2i times e to the I alpha minus beta minus e to the minus I alpha minus beta. Now we can use the exponent rule, since the exponents are a sum, so it's a subtraction, so we have to divide by I to the beta, or we can multiply by I to the negative e to the I and e to the negative I beta. So it will be 1 over 2i times e to the I alpha times e to the negative I beta minus e to the negative I alpha minus, so e to the positive I beta. And now we can use the Euler's formula identity. So e to the alpha will be cosine alpha plus I sine alpha, and e to the I beta will be cosine beta plus I sine beta, and e to the negative I beta and e to the negative I alpha are just conjugates of the complex numbers, which means we're just going to negate the y values, which means we are going to have a minus in front of the I alphas and the I betas. So what we're going to get is 1 over 2i times cosine alpha plus I sine alpha times cosine beta minus I sine beta minus, now we have cosine alpha minus I sine alpha times cosine beta plus I sine beta. Now we're just going to multiply everything out. So it's going to be a long expression. So I'm just going to write the 2i as follows, and then cosine alpha cosine beta minus I sine beta cosine alpha plus I sine alpha cosine beta. Then minus times I is plus sine beta sine alpha sine beta, doesn't really matter, minus, then we have cosine alpha cosine beta plus I sine beta cosine alpha minus I sine alpha cosine beta, then minus I times I, which is plus sine alpha sine beta. Now since we have this big expression, we just want to multiply the minus into everything. So this will become plus, okay, I'm sorry, minus. This will become minus, this will become plus, and this will become minus. So we can take the parentheses outside, and then we would actually have cosine alpha cosine beta minus cosine alpha cosine beta, and sine beta sine alpha minus sine alpha sine beta. Then we have 2 times of this and 2 times of this, so we can write it down as follows. It's going to be 1 over 2i times, I'm just going to write the I sine alphas, so 2i sine alpha cosine beta, then we have minus 2i sine beta cosine alpha. Now we have 2 i's on every pattern, so we can just cancel it out with the 2i which is in the front, since 2i is not 0. And we can now say that sine alpha minus beta is just equal to sine alpha cosine beta minus sine beta cosine alpha. I hope you enjoyed this video. Please like and subscribe. If you have any questions, please leave a comment, and we'll see us next in the definitely in the next Daishinfinity video. See ya.